Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us on the podcast known as Space Nuts. I'm your host, Andrew Dunkley. That's all I'm good at. And with me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Well, you're doing better than I am because I'm not good at anything.
Oh, yes, you are. Don't you start.
Yeah, thank you.
Otherwise, you wouldn't be jet-setting all over the world doing lectures and conferences.
Yes, and eclipses, which is...
And eclipses, yeah.
Actively doing this week.
Oh, wow, really?
2nd of July, that's right.
Fantastic. Which eclipse is this one?
It's the one in South America.
Okay, that'll do. I'm sure it'll be in the news, so people will be able to look it up.
It's in Chile, that's right. Yeah.
Now, we've got a bit to cover today. We're going to talk about Elon Musk's satellites because it looks like they're upsetting some of your colleagues, as they did, in fact, warn him about when he came up with the idea of putting all these internet satellites into space. Well, he's put some up there, and they're a bit brighter than people anticipated. We're also going to talk about the Star Trek logo because they found it on Mars. I don't know who dropped it, but it's there. It is really there. And a couple of questions. One from Brad about black holes and will they be easier to detect or see with the James Webb telescope? Good question. And Simon Street asks, is a singularity dimensionless? So we'll be focusing again a fair bit on black holes because people just seem to want to know more about them, Fred. So we'll try and fill in the blanks as much as we can. Now, let's get on to this issue of the satellites of Elon Musk. He's set up a few already. He's planning to launch about 12,000 of these things, and the astronomical world is a little bit agog, I think would be fair to say.
That's right. It's certainly a point of great discussion in the astronomical world at the moment because, it is something that will impact on the night sky and actually on the daytime sky as well for radio astronomers, because radio astronomers don't care whether it's day or night. They're still detecting radio waves. So what we're talking about here, well, this constellation of satellites in a project called Starlink. There are already 60 of them in orbit. They were launched in May. They're at orbits around about 500 kilometers. But Starlink, in its eventual configuration, will have more than just one shell of satellites, if I can put it that way. There will be some that are about double that height, and I think some that are slightly lower. I can't remember the exact configuration. But these things, 12,000 satellites in orbits around the Earth to give you what is effectively global coverage on the internet. That means wherever you are, you'll be able to be in touch with a satellite in the Starlink network. And the idea is to bring the benefits of space that we all, those of us who live in nations like the US, the UK, Europe, Australia effectively take for granted. But a lot of places in the world don't have that.
No.
They do not have that benefit. And so in that regard, this is it's got, I think, good motivations, although some have questioned whether imprinting the Western values on communications and things like that onto the entire world is necessarily a good thing. It depends entirely on whether the rest of the world wants it. It's not an easy ethical problem to solve. But the ethics are a bit clearer when it comes to putting a lot of stuff into space, because whilst astronomers certainly don't have the exclusive ownership of space, you can put it in very nice words. Actually, I might just quote an astronomer at the Lowell Observatory in the USA. One of my colleagues has just gone to work there. He says the natural night sky is a resource not just for astronomers, but for all who look upwards to understand and enjoy the splendor of the universe. And its degradation has many negative impacts beyond astronomical. And there is another comment that's been made, which is along the same lines. It's although astronomers can't make an exclusive claim to the night sky, neither can anybody else. So, it's not just SpaceX we're talking about here, because there are at least two other companies. I think Samsung are planning something called OneWeb, and there is also something called the Kuiper project, I think, which is Amazon's version of the same thing. And between them, they too will put up 10,000 satellites. So we're talking about mega plans here. Yeah.
Well, that prompts two questions in my mind, Fred. What are the rules when it comes to private people wanting to put stuff into orbit? Because I mean, is it carte blanche? Can they, if I want to do it, can I do it? Or are there rules about positioning and the other thing I think is congestion. What is going to happen with so much stuff up there that'll eventually become junk?
Exactly. So the first part is that, yes, there is some, there is some licensing protocol that relates to where you put things in orbit. It actually particularly applies to the geostationary orbits, which are much, much higher than the Starlink ones. Geostationary orbits are very, very tightly controlled because they're at a very specific height, 36,000 kilometers above the Earth's surface. So, but for low Earth orbit, it's a lot freer, although you can't try and inject a spacecraft into the same orbit that's occupied by something else, or else there'll be a collision. Yeah. And that is, just going to the second part of your comment there, that's one of the dangers with Starlink, that you've got all these spacecraft, very large numbers, and they weigh a third of a ton each or something like that. They're not small, they're not nanocubes, for example. So a collision would really inhibit the use of space further, because you've got debris all over the place, and you'd likely get a kind of domino effect with all these spacecraft at the same height. So yes, you're increasing. 12,000 is 2.5 times bigger than the number of operations and satellites at the moment, and then add another 10,000 to that. You're talking about staggering numbers, and collisions are not impossible. We've seen several collisions, some intentional, of course, as well. Yeah. So what's the reaction of astronomers? Well, a number of organizations have made statements about this. And I might just add as well that Elon Musk himself seems keen to listen to astronomers and listen to their concerns. So it's not a question of things being dismissed. There is a little bit of a surprise in that the planning that went into these satellites seems to have been slightly wrong, because the result of the estimates made during planning was that there would be no effect on the night sky.
I must just interfere here for a moment to say I have a couple of little guests that have come to say hello. Fred, I have my grandson here, Nathaniel. Can you say hi to
Nathaniel?
Fred? Say, hi, Fred. No, he's gone all shy on me.
I'm not surprised.
They've brought in lollies, so, it's very tempting.
Yeah.
Can you say hi to Fred?
Hello.
No, he's gone all quiet. And Annabelle, hello. Got a present for me, isn't that nice?
Oh, that's nice.
I'll come and get it later. I just got to finish doing this. Is that okay? They're going to go and eat their sweets.
Oh, that sounds good.
All right.
We'll hurry up.
Toddle off, and I'll be out in a minute, okay? And we'll play trains. Thanks, kids. Oh, they're so adorable. Sorry,
It's
Fred.
not fair. I want to
carry
play.
on.
Not fair.
No, they're terrific. Little cameo. Now, where were we? Sorry.
That's all right. Are you going to leave this bit in?
Yep.
So, ladies and gentlemen, welcome to the Grandfather Show with Andrew Dunkley.
Yeah.
Various grandchildren.
I knew they'd
Mine
come
are
in
all-
sooner or later. They had to.
Mine are all on the other side of the world, so it's unlikely to happen. Just going back to Elon Musk, though.
Yes.
As I said, he's, the planning suggested that there would be really no interference in the visual appearance of the night sky, but that's been proved wrong. These satellites are brighter than was expected. There is talk by SpaceX of, turning them in their orbit in such a direction that they're not directly reflecting light down to the surface to the same extent. That all remains to be determined. We're still in a stage where the community and the space community and the astronomical community sort of deliberating what the ultimate effect of this is likely to be. From what I've seen, Andrew, I think the professional telescopes that will be affected most are what are called wide-angle imaging telescopes that basically take in very large areas of sky and form images rather than doing spectroscopy and other clever stuff like that. And there are a large number of these. There's a thing called SkyMapper at Siding Spring Observatory. That's a substantial telescope operated by the ANU. The European Southern Observatory has 2 wide-angle imaging telescopes in Chile. The VST, the VLT Survey Telescope, is what VST stands for, and VISTA, which is another wide-angle telescope. So these are significant facilities that could find their work impacted by having satellite trails going across their images. Yeah. Now, the other side of this, as far as visual astronomy or visible light astronomy is concerned, is that the effect at moderate latitudes, which is where all big astronomical facilities are, is only limited to the first hour and a half or so of the night and the last hour and a half or so of the night, when the sun is reflecting off these spacecraft. During the middle of the night, they're invisible. So that's one mitigating fact. But still, they will have an effect. And there's no question but that they'll have an impact on astronomy. The impact on radio astronomers is likely to be bigger because these are beaming down 10 gigahertz signals down to the ground. That's right. Now, for us in Australia, it's not a great impact because the Australian square kilometre array antennas work at a much lower frequency than that. So they're blind to the frequencies that Starlink will emit. But it's still a consideration for observatories that work at higher frequencies. And one of those, for example, is ALMA, the Atacama Large Millimetre Array, which we've spoken about many times. Yeah. That could find its work compromised by this constellation of spacecraft. So it's a really interesting time we're in. And you can regard the first 60 satellites as a bit of a pilot project and certainly a wake-up study. Whether it will change the overall plans to launch the Starlink constellation remains to be seen. But I hope that we find a good outcome for all users of the sky.
Well, I must say it does sound concerning, and having 20,000 plus of these things up there, I just can't imagine it not causing some kind of problem somewhere along the line, and that must have a lot of people worried, and that's why it's in the news. So, yeah, let's hope common sense prevails. But space is wide open. It's a place that a lot of people want to be now, commercially and. Opportunities aren't being ignored, and this is one of them, I suppose. Okay, you're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, a reminder again that you can become a patron of this podcast by going to patreon.com/spacenuts. A lot of people have done so, paying a very small fee once a month to become a patron, but you get extra benefits as well as a commercial-free version of the Space Nuts podcast. We're also on Instagram at BitesHQ, BITESZHQ. On Facebook, of course, where a lot of people follow us all over Facebook. There are so many astronomy groups that our podcast gets posted to, and YouTube, of course. So hope you find a platform that suits you. Now, Fred, we mentioned at the beginning that they had found a Star Trek logo on Mars, and who dropped it? Well, Mars did, basically.
And indeed, that's right. So this is, yes, it's a lovely story about a landform on Mars that has been observed by the Mars Reconnaissance Orbiter spacecraft, which you'll remember has on board a camera called HiRISE, a high-resolution imager on the Mars Reconnaissance Orbiter, so it can take really detailed images of the surface of Mars. And in one of these, in the area known as the Hellas Planitia,
I just love the names of stuff on Mars. They have just nailed it there. They are brilliant.
Good stuff. But there's this view that is clearly the Star Trek logo on the ground. It's pretty big. I don't know how many meters long it is, but it's quite significant. However, it's not on its own, because when you look in detail, you find other examples all around it. You remember the Star Trek logo is a kind of crescent-shaped, I don't know, you might almost call it a tick with a short upstroke. Turn it upside down and you've got the Star Trek logo.
It's an upside-down Nike logo. That's what it is.
There's that too. But that, to a geologist, speaks of one thing only, and that is sand dunes. Because this is the shape of something well known. In fact, I learned about these at school. I did geology at school 100 years ago. And we talked about these things. They're called Barkhans, Barchan, Barkhan dunes. And they're formed when you've got wind predominantly from one direction. You get a sand dune that is crescent-shaped. And so what you've got here is not the dune itself, but a kind of fossil of the dune, because what is thought to have happened in this field of Barkhan dunes on Mars is that the dunes were formed by constant wind speeds, and then there was a lava flow, and the lava found its way around the dunes because the dunes were quite big and fairly solid, and so what you've got left is a kind of negative of what these dunes might have looked like. As the lava flow solidified, it left the traces of the dunes themselves. So there are these little chevrons all over that part of the surface of Mars. And as you said, it looks exactly like Star Trek logo, or if you turn it upside down, the Nike logo.
Yes, indeed. So there it is. Pretty simple, really, but it's certainly caught a few people off guard recently. So we thought we'd explain it. Now let's knock off a couple of questions before we finish up. Fred, Brad from Indiana. I think he's messaged us before. He says, "Hello, big fan of the podcast. Have a two-part question for Fred. Now that NASA finally got a pic of the black hole in our galaxy, do you think that the James Webb Telescope will pick up any more since it's a bigger, better telescope, or will it not pick up anything like that since it doesn't use radio waves for signal?" His second question will be, will NASA build a radio wave telescope to fly into space to look at black holes, or is that impossible? Love the show. Thanks, guys. Brad from Indiana. People, like I said earlier, people are just captivated by black holes, and now that we've got a photo of one, they're asking more and more questions about them. So part one of the question, James Webb Telescope, will it work?
Can I do part two first?
Yes.
Because what Brad asks in part two is, will NASA build a radio wave telescope to fly into space to look for black holes, or is that impossible? No, it's not. And actually, radio telescopes like that are one of the ways that we detect black holes, because it's the radiation that comes from the disk of material spinning into the black hole that actually allows you to pick it up. You can tell what you've got by looking at the frequencies that are emitted and things of that sort. And there are certainly radio telescopes in space. I'm not sure whether NASA operates one. I suspect they don't. The Japanese certainly do. So the second part of your question, Brad, is on the money, and it's not impossible at all. The first part, though, we're talking about two different things here. So Brad's first bit is, do you think the James Webb Telescope will pick up any more pictures of black holes? And he's comparing it with the one that we saw earlier in the year from the Event Horizon Telescope. And the answer is no. The James Webb Telescope is looking for infrared radiation. Now, accretion disks around black holes do emit infrared, so the James Webb will certainly discover other black holes. But what it won't do is give us a picture of it like the Event Horizon Telescope, because you might remember that telescope was effectively a whole array of radio dishes that mimicked a telescope the size of the Earth. The James Webb Telescope is 6.5 meters in diameter, and is not anywhere near big enough to resolve. It's not
effectively a bigger and better telescope for the purposes of photographing black holes.
It's not, but it's a good telescope for finding them. By the emission that they emit. You can't see the detail in it, but infrared is a good tracer of what black holes do when they're gobbling up stars, and the stars, whatever's disappearing into the black hole, whether that stuff actually emits infrared radiation. So yes, James Webb will certainly enhance our understanding of black holes, but it won't send back a picture like the one we saw earlier in the year.
Okay, and we're still waiting for them to take a picture of the one in the middle of our galaxy, but it's
I think they've already
a tougher prospect.
Yeah, I think they've already got the data. I think they're still working on it. So they took those images at the same time as the M87, was it?
Yeah. Glad your memory's working. Mine seems to want to take a bit of a break. But thank you, Brad, for your question. Appreciate it, and hope things are well in Indiana. It's an Indiana summer, I would imagine, which would be lovely, I think. Now let's move on to Simon Street's question. He says, great show. Which show is he talking about, I wonder? Anyway, love the astrophysics and the Northern Hummer from Fred and the Aussie Hummer from Andrew. I think he's talking about our accents.
We don't have accents, do we?
I don't think I do.
No, I don't
you do. I don't. Anyway, he's an amateur physicist. He said, I just want to try my hand at a couple of questions. Well, I will put a caveat here, Simon. We're going to answer part one. Part two, we're going to review because we're just not in a position to give you an answer to that at the moment. So we'll go with the first question that you've sent us. So a singularity is dimensionless, ? If so, are we talking quantum scales here? Let's assume physics doesn't totally break down. If the singularity has no size, both its momentum and position are known to an ultimate precision. So to avoid Heisenberg spinning in his grave, can we say singularities have a degree of fuzziness?
It's a great question. Simon's probably as well qualified to give the answer as I am, but let me have a shot at it. So what's he talking about here with Heisenberg? Werner Heisenberg, a great physicist who in, I think it was the 1930s, maybe the 20s, probably the 20s, postulated what is now known as the Heisenberg uncertainty principle, which is well proven in quantum physics. And that is that if you've got a particle, you can know either its position, which is easy enough, you can know its position, or you can know its momentum. Now, the momentum is the product of mass and speed. So it's like saying you can know its speed, or you can, because we know the mass of these particles, you know its speed, or you can know its position, but you can't know both with ultimate certainty.
Uh-huh.
So there's always got to be an uncertainty. If you measure the position precisely, then the speed is fuzzy. We don't know quite what the speed is, and vice versa. If you can measure the speed, you've got a fuzzy position for it. And so what Simon concludes from, or postulates from that, is that a singularity, which is the point in space where, yes, physics does break down and has no dimensions, it's what a black hole is there a degree of fuzziness in the position and momentum of a singularity? And from my thinking about what little I know of physics, I think the answer is yes. Black hole positions are probably at some level unknowable. If you know the velocity of a black hole, you can actually measure the velocity of a black hole by looking at the redshift of the light that it emits. You could probably measure the position at some level of accuracy, depending on what kind of telescope you're using and whereabouts it is. That's exactly what happened with the Event Horizon telescope we're just talking about. Very precise positioning of the instruments to determine the position of the black hole. But knowing both those two things with a high level of certainty is probably not possible. So yes, I think singularities do have a degree of fuzziness, just as I do.
Very, very good. And well asked. Thank you, Simon. That's a great question. He goes on and says, P.S. Thanks, Fred, for corresponding with me after my excitement about meeting Dame Jocelyn Bell Burnell. I don't know if you remember that, but I remember sending you on the email quite a while back. So, yeah, lovely. And we do try to answer people because we may not ask your question on the podcast, but we do try to answer some of them online, or we just acknowledge that you've sent it. I do try to get back to everybody when I can, and I hope I don't miss anyone. But if I do, I apologise. But we're getting so many now; it's just very, very hard to keep up. And I mean, I haven't got a secretary, and I'd be a pretty hopeless secretary as it turns out. So. We do the best we can, indeed.
You should recruit one of your grandchildren. They'd probably make a really good secretary.
They would, and once they got past their shyness, they would be doing a lot more talking than me.
Yeah, I'm sure that's right.
All right. Thank you to our questioners this week, our inquisitors, maybe, Brad and Simon. And thank you, Fred. It's just a lot of fun, and I look forward to the very next one.
So do I, Andrew, and I hope you have a great time with your grandchildren and enjoy your rest.
And we'll catch you very, very soon. Fred Watson, and he's Astronomer at Large. And from me, Andrew Dunkley, thank you to everybody who's listening. Thank you to our patrons. Thank you to our social media followers. We really appreciate it, and keep those questions coming in. We'll do our very best to get to as many as possible. But for now, that's it, and we'll catch you next time on another episode of
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.